This video is going to go over ways to help you solve problems dealing with right triangles on the SOL. The big thing that you need to remember is that there's only two methods that you need to know. And students a lot of times struggle to realize which one they need to use. So the way that I've broken it up is you use Sohcahtoa, trigonometry, whenever you have or need an angle other than 90. So when you have or need an angle other than 90 and it's a right triangle, you're going to be using Sohcahtoa. Use the Pythagorean Theorem at all other times. So let's take a look at the 8 questions that are on the last 2 released SOLs. So 4 questions is quite a bit. That's a good percentage of your test. So again, we start off with our question reading strategies. Which is the closest to x? So that's really all I need to solve for. It's x. I notice it's a right triangle and I have an angle other than 90. That's 20. So that tells me I'm going to be using Sohcahtoa. So whenever I'm using Sohcahtoa, I need to label the triangle. Across from the right angle is the hypotenuse h. On the other side of the triangle is O, and I also have the adjacent. So some students struggle with Sohcahtoa because they don't know which one to use. We have the adjacent and the hypotenuse. We do not have the opposite. So what we can do is we can get rid of these ones with the opposite. That means we're using cosine. So we do cosine and we put the angle right next to it. Cosine of 20 degrees is equal to adjacent, which is x, over hypotenuse, which is 80. Since x is in the numerator, it's up high. That means I'm going to multiply both sides by 80. So I have to get my calculator out. The thing that we want to make sure of is that our calculator is in the right mode. Whenever you go on your SOL and get your calculator, it will be set to radian. You have to go over to degree and change it. So make sure you go over to degree and hit enter. And then just hit clear. And we type in 80 cosine of 20. And we get our answer, which is 75.17. So our answer is just going to be D. Let's go on to the second one. So it says, which of the following sets of lengths can represent the measures of the sides of a right triangle? So we see we have a right triangle. We're not given any angles other than 90. We know there has to be 90 because it's a right triangle. So we're going to use a squared plus b squared is equal to c squared. So remember, c has to be the biggest side. So if we try the first one, that's going to be a, b, and c. So does 4 squared plus 5 squared equals 6 squared? The answer to that is no, so a is not the correct answer. So let's try a, b, and c again. Remember, c has to be the biggest one. Does 5 squared plus 12 squared equal 15 squared? Again, no. If you're unsure, we can do it in the calculator. A, B, and C right here. Does 8 squared plus 10 squared equals 17 squared? No, it does not. The correct answer is going to be D. So we have A, B, and C. Does 20 squared plus 21 squared equal 29 squared? The answer to that is yes. So I would suspect that a lot of you would need to put all of these in the calculator. That's fine, but 20 squared plus 21 squared is 841, and 29 squared is 841. So that's why D is the correct answer. So we have this one here. It says, what is x? The height of the equilateral triangle. There are actually 2 different ways you can do this. We'll solve it using Sohcahtoa because we do have an angle. We have 60 degrees. We also need to have a side though. That's one reason why this is kind of a tricky problem. We actually have two sides of this. It's an equilateral triangle. So this side has to be 14. Remember our original triangle, all the sides are equal. You should also know that when we fold 14 in half, we're going to end up with 7. So you should see that we can use the Pythagorean theorem, but since we have an angle, we're going to use our rule of this right here. So this is the opposite, and we can use any side we want. Probably the hypotenuse is easier to find. We just need 2, so we're going to use Sohcahtoa. So in this example, we're not using the adjacent. Even though it's there, we're going to use the opposite and hypotenuse. So the sine of 60 degrees is equal to x over 14. Once more, x is in the numerator. It's up high. We multiply. So 14 sine 60 will get us an answer. It's going to be 12.12, and I look at my options and I say, well, I don't see 12.12. Maybe that's 14 square root of 3. It's not. Maybe it's 7 square root of 3, and that's going to be my answer. So if you're familiar with special right triangles, you're probably looking at this and saying, why didn't I just use special right triangles? That is actually an easier way to do this, but it's one more thing to remember. The point I'm trying to get across is we can do all of these problems with either Sohcahtoa or the Pythagorean theorem. So if we look at this problem right here, there's our keyword which. Again, it's below the diagram. Which is closest to the length of the 6 cars? So the 6 cars are right here. That's going to be x. I have an angle. Since I have an angle, Sohcahtoa. By the way, it's a right triangle. I already kind of assumed that you knew that, but we use Sohcahtoa or the Pythagorean theorem on right triangles. So I labeled the triangle. That's the hypotenuse, and this is going to be the opposite. Remember, the opposite is based off of where the angle is. I do not have the adjacent, so I'm going to be using sine again. So the sine of 38 degrees is equal to opposite over hypotenuse, 20 over x. So in our other problems where we were using Sohcahtoa, x was in the numerator. This time it's in the denominator. So the trick that I told you to remember was denominator divide. We're going to switch these two around. So x is going to be equal to 20 divided by the sine of 38 degrees. So I'm going to use alpha, y equals enter, 20 divided by the sine of 38. So my answer is going to be 32.48. That's closest to 32.5. So here's another problem that we have to use right triangles. This might be kind of hard to recognize because it says, which is the side length of a square? So when we think of a square, let me use my shapes to help me out. When we think of a square, we should be thinking of a right triangle. All the sides are equal in a square. So you should see that outlined in red here is a right triangle. Do I have or need an angle? Well, if you know more about squares, you should know that this is a 45, 45, 90 triangle. But as it stands right now, no, we do not have an angle in our picture. We have all the sides though. So we can use the Pythagorean theorem. X squared plus x squared is equal to 14 squared. What is x squared plus x squared? It would be 2x squared. 14 squared is 196. We divide by 2. X squared is equal to 98. And we take the square root of this. So we get 9.899. It goes on forever. So we need to see which one of these would be the right answer. So let's go through our options. 7 square root of 2. There we go. It's the first one. So that's going to be our correct answer. Once again, if you're good with special right triangles, it's probably easier for you to solve this using special right triangles. But because I want to demonstrate that all the problems can be done with Sohcahtoa or the Pythagorean Theorem, that's why I didn't use it in this problem. Okay, let's look at this one. We have a right triangle, so again, Sohcahtoa, Pythagorean Theorem. Which angle measure is closest to the value of x? So this time we need an angle. That means we're using Sohcahtoa. Remember, it's when you have or need an angle, you're using Sohcahtoa. So we label the triangle. Out here is the hypotenuse. On the other side of the triangle is the opposite, and this would be the adjacent. So we have the adjacent and the opposite. We do not have the hypotenuse. So that tells us we're going to use tangent. So just like with sine and cosine, we always put the angle next to tan. This time the angle is x. It's going to be equal to opposite 8 over adjacent 7.8. So this time we have x next to sine, cosine, or tangent. So to solve this, we have to use arctan, or tan negative 1, 8 over 7.8. So in your calculator, you need to hit second before you hit tan. That's how we get the negative 1. And I'm going to set up as a fraction, 8 over 7.8. And I get my answer of 45.72. So that would be C. This one here, it's a right triangle. The problem here says select the measures that could be the 3 side lengths of a right triangle. So I do not have any other angles besides that right angle. That tells me I'm going to use a squared plus b squared is equal to c squared. So I need to try some things out. Maybe 17 squared plus 20 squared is equal to 21 squared. Or maybe 17 squared plus 21 squared is equal to 29 squared. Or my third option would be 20 squared plus 21 squared is equal to 29 squared. So remember, my largest number needs to be C. The correct answer will be this one here. This one encourages you to try things, which is sometimes a little bit uncomfortable. But our answer would be 20, 21, and 29. We actually saw this in a different problem earlier in this video. And this is going to be the last one we're going to do in this section on right triangles. It's a right triangle again, and we have an angle. So when we have or need an angle, we're going to use Sohcahtoa. So since I have 22, this is the opposite, hypotenuse, and I do not have the adjacent. So that means I'm going to be using sine. So I write sine, and I always put the angle next. Sine of 22 is equal to opposite, which is x, over 15. When x is up high, I need to multiply. So I multiply 15. So my final answer here is just going to be 15 sine of 22, and it's 5.6. So D is the answer. I really hope you understand this video, and if you do, any problem with a right triangle should be an easy one for you. And if you look at it, 4 problems per SOL, that's a good way to make sure that you're going to pass the test.